Previously we looked at getting the inverse of a 2 by 2 matrix. Now in this section we look at getting the inverse of a 3 by 3 matrix. Now in normal maths, if you multiply any number by its inverse or its reciprocal, we get 1. So for example 8 multiplied by 1 over 8 is 1. In matrices, if we multiply the matrix A by its inverse, we get the unit matrix. So how do we get the inverse of a 3 by 3 matrix? Well, the inverse is defined as the adjoint times 1 over the determinant of the matrix, or 1 over the determinant multiplied by the adjoint. And the adjoint, which is a new concept, is found by forming a matrix B of all of the cofactors of the elements of A, and then transposing the matrix to give the matrix BT. And this matrix, or the transposed matrix, is called the adjoint. So let's have a look at calculating the inverse using this technique. Here we have a 3 by 3 matrix. We're asked to form a matrix B from the cofactors of A. We're then asked to transpose B to give the matrix BT, which is the adjoint of M. We're then asked to find the determinant of M, find the inverse of M, and then show that the inverse times M is equal to the unit matrix. So first of all, let's look at calculating the cofactors of each of the elements of the matrix. Now remember, to get the cofactors of any element, we cover the row and the column containing the element, we get to the determinant of the remaining 2 by 2 matrix, and we check its sign. So let's first write down the minor, and this is called a minor of an element. So let's write down the minors of all of these elements first of all. So the minor of the element 4 is obtained by covering the row and the column containing 4 and getting the determinant of the matrix 1, 1, 2, 0. The minor of the element 2 is found by covering the row and the column of 2 and getting the determinant of the matrix 0, 0, 1, 3. The minor of the element 0 is found by covering the row and the column containing 0 and getting the determinant of the matrix 0, 1, 3, 2. So we repeat this procedure for the second row. So for the first element of the second row, the minor is the determinant of 2, 0, 2, 0. For the second element of the second row, the minor will be the determinant of 4, 0, 3, 0. For the third element, the minor will be the determinant of 4, 2, 3, 2. And finally, for the last row, the minor of the element 3 will be the determinant of 2, 0, 1, 1. The minor of the element 2 will be the determinant of 4, 0, 0, 1. And for the last element, the minor will be the determinant of 4, 2, 0, 1. So these are the minors, and if we now put in the sign pattern, which will be plus, minus, plus, minus, plus, minus, plus, minus, plus, this will give us the cofactors. So we work out the determinant of each of the elements. So we'll do a few here. So that'll be 1 minus 2, which will be minus 2. This will be 0 minus 3, which will be minus 3 by minus 1, which is plus 3. 2 times 0 minus 3 will be minus 3. This will be 0 and minus 0. This will be 0 minus 0. Here we have 4 2's 8 minus 6, which is 2, and its sign is minus, so it'll become minus 2. This will be 2 minus 0, which will be 2. 4 minus 0, which is just 4, and we multiply this by minus 1, we get minus 4. And 4 minus 0 will be 4. So this is the matrix of the cofactors of all of the elements of M. So now we were asked to transpose this matrix to give the adjoint. So if you remember from before, to get the transpose, we take any row. So let's take the first row, minus 2, 3, and minus 3, and we write it as a column. So this row becomes minus 2, 3, minus 3. We then take the second row, 0, 0, minus 2, and write this as a column. So it becomes 0, 0, minus 2. And we take this row here, 2, minus 4, 4, and write this as a column, and we get the column 2, minus 4, 4. So this is the transpose of the matrix B, and we call this matrix the adjoint M. So now we were asked to determine the determinant of n. And again, if you remember, we get the determinant of a 3 by 3 matrix by multiplying the elements of any row or any column by the cofactors of that row and that column. So in this case, I've picked the first row and the first column. The first row of the matrix and the first row of the cofactors. So the determinant will be 4 times minus 2 plus 2 times 3 plus 0 times minus 3. So that's going to be minus 8 plus 6 plus 0, which is minus 2. So this is the determinant of the matrix. And now we're asked to calculate the inverse of the matrix. And if you remember, by definition, the inverse of a matrix is defined as the adjoint of the matrix multiplied by 1 over the determinant. So we know the determinant is minus 2, so it's going to be minus 1 over 2 times the adjoint, which is the matrix minus 2, 3, 3, 0, 0, minus 2, 2, minus 4, 4. And that's the inverse. Now, in the last part of the question, we were asked to show that the product of the inverse times the original matrix is equal to the unit matrix. So here we have the inverse, here's the original matrix. So if we multiply these two together, remember we have the first row times the first column, so it'll be minus 2 times 4, 0 times 0, 2 times 3 for the first element, minus 2 times 2, 0 times 1, 2 times 2 for the second element, the first row by the third column for the third element, which would be minus 2 times 0, 0 times 1, and 2 times 0. So we do this for the other rows and columns. So it will be the second row times the first column to give us this element, the second row times the second column to give us this element, the second row times the third column to give this element, and then finally the last row by the first column to give this element, the last row by the second column to give us this element, and the last row by the third column to give us this element. And if we multiply these out, these should all work out to be 2, 2, 2 in the leading diagonal. So let's just check one or two of them. So we have minus 8 and 6 will be minus 2, and then that should be minus 2. Let's check this. This will be 4, that'll be 0, 4, minus 4 plus 4 will be 0. This will be 0, this will be 0, this will be 0, so that term will be 0. This will be 12 minus 12, which will be 0. This term will be 12 minus 12, which will also be 0. So if you check the other terms, we should get this matrix here. And if you remember from before, if we multiply a matrix by a scalar, in this case minus a half, we multiply each of the elements by the scalar. So 2 into 2 goes 1, and because it's minus by minus, we'll have plus 1. So as we can see, the inverse multiplied by the original matrix is indeed the unit matrix. So here's one you can try. So stop the video and you're given again a 3 by 3 matrix. Again you're asked to form a matrix B from the cofactors of M. You're then asked to transpose B to give the matrix BT, which is the adjoint. Find the determinant of M. Find the inverse of M and show that the inverse times M is the unit matrix. And there's the answer if you want to check your work. Finally, here's a question. Again, you're given a 3 by 3 matrix and you're asked to calculate the inverse of A. And once again, the answer in this case is given here.